Hello, in this episode, we'll discuss about autoencoders. So this is something that probably is technically very similar to what we have done in supervised learning. It is a network that basically has an input here, like for example, the MNIST image that we have seen. Okay? And then it goes through some middle layers, it can be multiple. But then eventually it has an output, and the output is unique in the sense that in the training process, we will give the same input as the output. So the input is the output. So we give the same here, right? And after training, what it will do, we are hoping to do is that, so if we give an image and go through a network, it will reproduce the output, okay? Typically in the autoencoder that for our purpose, we'll typically have a bottleneck, like the number of nodes will shrink down to a smaller size and then be blown up to the original size, okay? So from the input to, well, multiple layers if possible, and then to the bottleneck is called encoder. And from the bottleneck up to blowing up again to the original input node will be decoder, okay? So we get, for example, in the handwritten digits, if we want to recreate that, then here's the original input, we put a decoder and this bottleneck, which sometimes we call it latent space, and then bring it back up to decoder and reconstruct it, okay? And the latent space, if it were two-dimensional, I've showed here, can be looking like this. So, and what's interesting is that different digits, like from 0 to 9, tend to cluster around together. So you can see this interesting properties here. So in terms of technicality, it's just a neural network with several layers. Okay? So technically writing the code is not too difficult and different from what we have done before. Let's just look at here what it is. So we are going to use TensorFlow Keras library, it's going to be a simple supervised learning kind of neural network. We'll use MNIST data. So I'm going to use Keras library, the MNIST data here. I'm going to load MNIST data that we have seen and scale it to make the values range from 0 to 1 and flatten it to 784 columns to flatten the 2D image. Okay, so here's an autoencoder network. It starts from 784 input node, then goes to 512 nodes, 128 nodes, and then a bottleneck of 2 nodes. And then we bring it back up to 128 nodes, 512 nodes, and 784. Okay, bring it to original image. The middle layers are typically ReLU, except the middle layer. I'm going to keep it linear. And then again, the ReLU and the output, because I scaled it range between 0 and 1, just to give a better performance rather than a linear, I'm just going to give a sigma. Okay? So this is the autoencoder. It's like supervised learning, except that you're going to put your input image back in the output also in the training process. So here is the training. So X is the input and X train is also the output. So that's why it's called an autoencoder. So this is going to take a while. Okay, so it's done training. So let's see how the encoder works. So here's the encoder. And we are using the X test data here. Okay. So in the autoencoder network, so this is the autoencoder, we name it the autoencoder of the input, and then get the values from the layer encoder output. So, and when we defined, we actually gave a nickname here, encoder output. So I want to get the input to up to the output here, so which is in the bottleneck area. Okay. So, and if I give an X test data, what will be the two-dimensional image? Okay, it looks like this, but let's see in a picture. It will give me something like this. Right? How about the decoder? So it's an autoencoder, just predict the whole thing and reconstruct the image up until the output. Right? So, and I'm going to construct the X test and the decoder output, the reconstruction error, and to get the errors. So how does it perform? In terms of number, it's hard, but let's select the image, the first one in the test data, which was a 7, digit 7. So and reshape it to 28 by 28, and then plot the 2D image. This is the original image. The reconstructed image, okay, the reconstructed image x hat, okay. The x hat is here. We get it from the reconstructed image, isn't it? X hat plot. Okay. Yeah. So let's plot that, and how it looks like is not quite as good as the original image, but it seems that the algorithm works. Okay. So this is about the autoencoders and how to implement it using the MNIST data. Thank you for watching this episode.